Air resistance. In this video we're going to talk about drag, and in particular related to projectile motion, air resistance. Air resistance is a force that acts in the opposite direction to the velocity. So in this diagram on the screen, it will be opposite the purple arrow, so in the direction of the green arrow. As air resistance is dependent on velocity and is in the opposite direction to velocity, it tends to slow down the object both horizontally and vertically. So let's look at the problem horizontally. To begin with. So previously, when we were looking at a scenario in the absence of air resistance, there was no forces in the horizontal direction, so a projectile can continue moving at that same velocity forever. However, with air resistance, as it acts in the opposite direction to velocity, it slows down the object in the horizontal direction, meaning the maximum range of the projectile is reduced. Now considering the vertical component of motion, I want to look at the way up first. So previously, the force in the vertical direction was gravity, which pulled the object back down. Now since the object is moving upwards, the velocity is upwards and the drag force is also down. So with the drag force being down and gravity being down, the object doesn't reach the maximum height that it previously would have in the absence of air resistance. This also results in the time taken to reach maximum height being reduced. On the way down, the velocity of the projectile is in the down direction. However, the drag force is in the opposite direction, being up. From the maximum height, this results in the object taking longer to hit the ground as if it weren't subject to air resistance. So overall, with air resistance effects, the object's maximum height is reduced as well as its range and time of flight. Velocity is the major component that affects air resistance, however there are other factors as well. The shape of an object, its size or cross-sectional area, as well as the texture of the object affect its drag. The mass of an object doesn't affect the drag on it, however it does affect the degree to which the projectile's motion changes. I'll give you an example of that in a sec. This is the drag equation, however you don't need to know it for the course, but you can see the important factors that are involved in determining the drag on an object. With that squared term on velocity, that means it's the most important and influential factor in terms of drag. However, the other terms include the density of the fluid, and in our case in projectile motion, the fluid is air. The cross-sectional area of the object makes a difference, so a smaller object will be more aerodynamic or have less drag than a larger object. The drag coefficient is also important, which relates to the shape and surface texture of the object. So you can see that mass is not involved in determining the drag of an object. However, let's compare two objects of similar size, being a golf ball and a ping pong ball. So both have relatively similar surface textures, and if you throw them through the air at the same speed, the drag force on them will be exactly the same. However, from experience, the golf ball will travel a lot further than the ping pong ball, but why? So as the ping pong ball is of a lower mass, that drag that is on it influences its motion a lot more than the golf ball, which has a larger mass. Terminal velocity is a term that we use when the maximum speed of an object is reached when moving through the air. At this velocity, the downward force of gravity is matched by the force of the drag in the opposite direction. So what this means is that the object has balanced forces and is not accelerating down or up and keeps a constant velocity. An easy question for you today. Name 4 factors that can affect the drag of an object.